Tangent, in terms of x's and y's, tangent is what over what? Opposite over adjacent. Good. Now in terms of the ordered pairs, y over x. Very good. So tangent is y excuse me, over x. And what I like to do when I start working with tangents, just like we did with sines and cosines, I'm going to bring it back to the unit circle. So let's draw out a quick unit circle and put the quadrantals in. Let's see, it's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. As we go around the circle, one full revolution is how much pi? 2. 2 pi.
2 pi.
So this is a 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's think about this. There was another critical point of tangent that occurred at the unit circle that was very easy to work with. What was that point, do you remember? Where was tangent very easy to work with? 45s. At pi over 4. Everybody remember that? At pi over 4, sine and cosine were the same value. Root 2 over 2. So tangent was always 1 at pi over 4. So at every multiple of pi over 4. Positive 1 here, negative 1 in the second quadrant, positive 1 in the third quadrant, and negative 1 again in the fourth quadrant. So here's what we're going to look at. What happened, or what is the tangent of 0? What's the tangent at 0? 0. 0 divided by 1. Tangent of 0 is 0. What's the tangent of pi over 4? 1. What's the tangent of pi over 2? Undefined. How do you graph an undefined value? What do we put visually on the graph then? Not a line, it's the, remember the asymptotes? Remember when we graphed, remember when you did this stuff, 2 over x minus 3, what couldn't x be? Couldn't be 3. You had a vertical asymptote if you divide by 0. So at pi over 2, you have an asymptote. Go the other direction. What happens at negative pi over 4? Negative pi over 4 is going this direction. What's tangent at negative pi over 4? Negative 1. What's tangent then at negative pi over 2? Asymptote. So if I'm looking at just that snapshot, what's the distance between the asymptotes?
Pi.
Pi. Good. The distance between these two asymptotes is pi. What is happening to the graph as you're going from left to right? Very good. It's increasing. So what tangent does, it increases from negative infinity to positive infinity between negative pi over 2 to pi over 2. Every single tangent graph looks like that. The period of every single tangent graph is always pi. This happens, this asymptote happens as you get from pi over 2, then you jump to the next pi over 2, pi over 2, pi over 2. As you, each time you go a pi value between pi over 2 and a negative pi over 2, you're going to reach some asymptote. Well, I should say reach the asymptote. You're approaching the asymptote. Tangent is very, very simple to work with. You have basically 3 points you're always going to plot. Origin, the halfway between 0 and your asymptote, and then you put in your asymptotes. The asymptotes will always be placed pi apart from one another. All right. So let's look at what the actual tangent equation is. Y equals a tangent b of x. Tangent doesn't have a specific amplitude. There's no maximum height to a tangent function, or there's no minimum height to a tangent function because of that asymptote. It's always increasing as it's getting infinitely closer and closer to it, or it's always decreasing as it's getting infinitely closer. So the amplitude is going to help us find one of those critical points here in a little bit. The b value does allow you to find your period. The b value for your period of tangent is always going to be pi divided by the absolute value of b. More often than not, our b values are going to be positive with these things, just so you guys know. And the other thing that happens with tangents is that you have those asymptotes. Your asymptotes are always going to occur at odd multiples of pi over 2 times the absolute value of b. This isn't as important as the book likes to write. I like to make it a little bit more visual. You'll see that here in a second when we work an example. All right? Let's do an example of a non-shifted one. We'll talk about the shift, and it goes from there. Oh, there you go. Let's look at this. Y equals 3/2 tangent of 4x. Yes. Yes. What we're doing here right off, I'm going to do one example of just the parent function, then I'm going to do one example of the shift, and do you homework problems. It is very, very straightforward. Okay? Again, just like we did yesterday and the day before, whenever we start with these trig graphs, we're always going to list out our A's and B's, and then in a minute here we'll also label the H and K. What's my value of A? What's my value of B? Good. So I start with that. A is 3/2. B is 4. That means my period is going to be pi over 4. That means my asymptotes will be placed pi over 4 apart. Yes, sir?
Does that mean that it's pi over, like here's the origin? Does that mean it's pi over 4 from here, or the whole thing?
The whole thing. The distance between the two asymptotes will be pi over 4. So when I go to make my graph, one suggestion, when you make tangent graphs, make them a little bit wider than what you think you're going to, because you have the extra points you're going to put in between them. Especially when you do the shift, you'll have some very simple, you'll just make it a little bit bigger than you need to. I know that this distance between here and here is going to be pi over 4. And since the parent function is always mapped around the origin, that means the origin is the halfway point. So what's half of pi over 4? So that means that my asymptotes are at pi over 8 and negative pi over 8. Are we okay with that? Now, the next critical value occurs between 0 and pi over 8. What's halfway between 0 and pi over 8? Good. Negative pi over 16. What's that?
How do you get pi over 8? What is that?
The distance, the period of tangent, this is pi over 4. Okay? This whole distance between here to here. It goes past the origin. This is symmetrical on both sides. So these two distances are equal. So this side has half of it, this side has half of it. What's half of pi over 4? Pi over 8. Here's another pi over 8. Pi over 8 plus pi over 8 is 2 pi over 8, which is pi over 4. That's where I got my asymptotes. Yes, sir?
So your asymptotes will always be half of the period?
Yep.
So the whole thing together is pi over 4.
Yes.
And, okay.
Yes. The other part here is these breakpoints. Think about when we graphed it at, oops, where was it? We graphed it here. This distance, this pi over 4 value was always giving us a 1 for tangent. because it was halfway between 0 and the asymptote. That occurs also when I'm here. This halfway point between 0 and the asymptote will still give me my A value. This, when I'm at pi over 16, I'm going to reach my A value. Since my A value is positive, I know that I'm increasing. I know it goes through the origin. I know that at negative pi over 16, it's going to occur here at my negative 3/2. And that's my curve. Tangent is sectioned off halfway points. Yes, sir?
It was y equals negative 3/2,
Then it's going down and to the right.
then it's just gonna be like that.
Yep. Yep. My next example has a negative. Halfway points. It's halfway.
So 3/2, and then that just goes in between.
That's the A value. The A value is going to be what the height of the halfway point between 0 and the asymptote will be.
But where do you,
Yep.
how do you figure out where it goes?
Yes, sir.
How did you teach before you had
Just like
smartphones?
I had really bad handwriting.
Yeah,
Yeah.
just be like on whiteboards.
Yeah, I used a lot of whiteboard.
That's what is-
Yeah, we'll get to that when we do the when I do the shift ones. Yes, I just wanted to show you a non-shifter because basically this is the parent function. And when we do the parent function, we'll write out the ordered pairs. It's very easy to add and subtract in your H's and K's to your ordered pairs when you're working with the shift stuff. What's up?
But like the quiz, if we're just getting an equation that's a parent, do we have to write the,
I'm not gonna. I'll give you a shift. All of them be shifts. Okay. So let me show you one here for the shift stuff. Again, when I'm working with H's and K's with tangents, it works the exact same way as it did with sines and cosines. The H is your horizontal shift, your K is your vertical shift. Everything gets moved, whether it's one of those 3 critical points, but also the asymptotes have to move. Now, will the asymptotes move horizontally, vertically, both?
this one?
Yeah, the asymptotes are just going to move horizontally. Because if you move a vertical asymptote vertically, isn't it still in the same spot? So you just have to move your asymptotes horizontally. Again, what we're going to do here when we start these problems, just like we did yesterday, label out A, B, H, and K, and we'll find the period right away. What's A? What's B? H? And K.
Just toe.
What's my period?
Just two. No.
My period is pi. Remember, the period for tangent is always pi over b.
Oh, I was looking at that.
That means your asymptotes then will be at plus or minus pi over 2. Good. So we'll start this one. Just a little bit. I do have to go vertically up a little, so let's move that one down a little. We know that the original parent function is going to go through the origin no matter what. I know the period between that is pi. So that means on 1/2 is pi over 2. The other half is negative pi over 2. When I go through, put my asymptotes in to start. And I go from there. What's halfway between 0 and pi over 2? 4, good. And then on the other side is negative pi over 4. My A value is -2, which means it's decreasing from left to right, which means that all I have to do is mark off 2 of them then. If it's decreasing, that means that at negative pi over 4, it's at +2, 0, 0, and pi over 4, -2. And there's the curve. Again, tangents are very simple to plot. You're only really looking at 3 points. Negative pi over 4 and 2. 0, 0. Those are those 3 points. Everybody okay with that? Now the shift. The easiest point to move first is what? 0, 0. Everybody agree that at 0, 0, it's what's the new point? Yeah. Yes, the parent function is always going to be, it goes through the origin at 0, 0. Always, always, always. All right. What's it at?
2, 0.
What's your h? Negative pi over 4. Oh, shoot. So that means my new ordered pair for the new origin will be at where? H goes first. It's going to shift over to negative pi over 4 and 2. That's where the new origin goes. All right. A is negative. It's going the other direction. Nope. It's reflected. Just like with sine. Remember how sine went the other direction? Instead of going up first, it went down first. Cosine, instead of going, cosine started at top, worked its way down and up. Cosine, when it's in negative a, it works down, or excuse me, it works up, then down. It's just going the opposite direction. That's all it needs. So here, what's negative pi over 4 minus pi over 4? Positive or negative? Okay. What's 2 plus 2? What's pi over 4 minus pi over 4? What's negative 2 and 2?
Back at the origin.
So this one just moved over to the origin. Now, when I move my asymptotes, again, all I'm looking at is I have to move pi over 2 left pi over 4. So what's 1/2 minus quarter? Quarter. So the new asymptote on the right-hand side is at pi over 4. What's the new asymptote on the left-hand side? Yeah, good. So now, what happens a lot of times when you have the tangents, you're going to have asymptotes going everywhere and curves and dots and stuff. It does look a little bit messier. I will suggest that you make your tangent graphs wider than what you really need to, just so it helps clean it up some. All right, it helps clean it up some. Go plot. Point on the right is at 0, 0. Pi over 4 and 2. Negative pi over 2 and 4. And there's my curve. Yep. What you're doing is you're plotting out with 3 points and then moving your asymptotes. That's tangent. Not that bad, I'm hoping. Yes, sir.
Quote of the year.
What's that?
Quote of the year.
Yes. You didn't see that yesterday?
No. Is that really funny?
It was hysterical.
It
It was in, yeah.
MLA format?
Yep, MLA format. I got yelled at to make sure I put MLA format in there. When you guys will never use MLA format anywhere in your lives, everything goes APA when you get to college.
That's great.
Hey, is APA what, as like a section and then you write a little? What is that?
I don't know. I wrote so many papers in APA and I forgot it.
What is APA?
American Psychologists Association or something like that. I don't know. It's annoying.
APA, why don't we do that? Because we're stupid.
No, because
Why are we learning the
I know that a lot of papers that I wrote in college were all APA, and we never used them. But it depends on schools. I don't know.
Jason was probably saying something just like consistent.
Yeah, it depends. It depends on what I was doing. I had everything I had to do was APA, and it wasn't science related, but it wasn't math related. Really? No. So it all depends on where you're at. Okay.
Don't touch me.
Questions?
I like him so great.
Let me give you some of these to try. This is on page 845 again. This is section 14.2.
His dad's there, bro.
They fouled him 4 times.
Again, when you're working with these shifts, list out your 3 sets of normal ordered pairs, and then go with the shifted ordered pairs. And just relabel out your asymptotes, okay? It's the same page. I didn't go back to 14.1 of the tangents because you have to be able to plot a parent graph to be able to plot a shift. Okay? We will combine a bunch of this stuff up tomorrow. I might try and throw a couple of tougher ones at you. And then we'll quiz out of this stuff on Friday still. All right? No thanks.
Picture of you, Cassie. Ha! Trying to kill us.